Yeah, I wanted to tell you something about our experiences with the IASI profiles at the testbed, and also a couple of other evaluations that we did where we looked into actually quite many different cases, and we tried to get an idea of how useful the IASI profiles would be for monitoring, but especially for nowcasting or short-term forecasting of severe convection. So I'll briefly, oops, this is not what I want. Here we are. Yeah, so I will tell you a little bit about this. So we actually had a formal project that we were asked to carry out by EUMeTrain. And part of this was, as I said, to evaluate the use of these hyperspectral sounding products and assess the potential of such products, especially given that we will have the infrared sounder on the MTG satellites, also to get some practical experience. So we really had forecasters and other researchers, developers from other weather services who visit us at the testbed, who would really use this and try to see if they could improve their forecast using this data. Very important was, of course, to collect feedback, all kind of feedback, ranging from how useful the way was that we displayed it to really the quality of the profiles. Like, does it make sense, or does it give additional information compared to the data that you already have available from numerical models, for example? That's essentially what I said here. So yeah, and the third thing was, of course, that we also wanted to raise awareness among all the people who visited the testbed to yeah, to the existence of these profiles. And fourthly, to consolidate the product requirements for the level 2 IASI product. So what did we do? First, we integrated this data into the testbed platform and developed visualizations of the data. Then at the second point, we did the evaluation at the testbed, where we collected this feedback, and we also performed 10 case studies. And that was not directly related to the testbed, but we looked back at a couple of cases, and also those that occurred before the testbed. So before the summer of last year, when we carried this out, and we also developed an extended case catalog. So we have 40 cases defined where we know that severe storms happened, where we know that either they were difficult to forecast or they had a really big impact, and there was a few cases where actually not much happened, even though the model suggested that there could be a lot of severe weather. So these are really yeah, the most interesting cases from especially 2019, 2018, and 2017, where we thought it would be helpful for people at EUMeTrain to look into a little bit more in detail. And we also provided a small training at EUMeTrain, of course not on the IASI sounder, but more on the part that ESSL has a lot of expertise in, so especially the ingredients-based forecasting of severe convection, and then sort of to indicate the interface, like where does this interact with actually where the IASI product, but also other products from new sensors or existing sensors on the Meteosat and the polar orbiting satellites actually can contribute to. And then finally, we have a report. Of course, it's not a draft anymore. So this was a quite long report, especially because we had all these cases described in there. But the first part is really readable, and I can recommend it. So to start with the first part of what we did, so this is what the testbed platform looked like last year. So on yeah, in the center here, you essentially have different model fields, and you can see, yeah, you can see. Well, this is a particular example of the 850 hectopascal map, where you can select various variables here on the left. On the right here, you can select various domains in Europe, and yeah, and this is of course the most important button. If you click on that, you will activate the sounder data. So whenever you have selected a time here at the time bar at which there are IASI measurements present, you will actually see the dots, and they appear over this data. So that should normally be on my second slide. Stop annotating first. That helps. Yes. So I will show you what this looks like in a moment, just to keep it a little excited here. The other way that we try to give people access to the data is to visualize it by using these kind of QT diagrams. So these are the diagrams that show the temperature with altitude or with decreasing pressure, and the humidity with these red and green contours, from which you can read the convective available potential energy, the CAPE, and the convective inhibition. And there's some other model-derived data available as well here. There's some parameters like storm relative velocity and so what we did is we especially focused on the ingredients-based methodology whenever we wanted to visualize one of these parameters on the map. And we coded this up in Python. There was so these are a couple of parameters that you can look up, and we have delivered this code to EUMeTrain so that they can compare it with their existing code, from which they also derive a number of these parameters. So this is a first look at what, for example, if you would first zoom in to our domain called Central. So this is this area here of Central Europe. If you would then select this IASI sounder data, and you had as a model parameter already these 50 millibar mixed layer CAPE selected, then you would see these dots, which actually are display the same variable in the same color scale. So this is a way of comparing that actually we sort of took from Sophia, who we knew had programmed a similar visualization already before. So we found this really very attractive way of presenting the data to people, because it is immediately obvious where the two data sources, so the model in the background and the dots from IASI, do not agree with each other. So for instance here over, let me see, I can annotate. So if you would look here, here's some area where you have an underestimation by IASI or an overestimation by the model. Of course, it's always important to know who is the best. Yeah, is the model off here, or is maybe IASI off? And why could that be? There's also places where there's actually a good agreement, like here a little bit further south, where there are a couple of places where there's actually quite a lot of agreement. So this would be comparing a 9-hour forecast from the ECMWF model with actual observations at that time. So the other way to compare the data is that we also integrate the IASI profiles in our so-called roaming sounding tool. This means that whenever you select this option and you then move your mouse over the map, you will see the profiles change from one location to another. So maybe I have to explain it. There's quite a few lines in here. So we have the model temperature here in the thick red line and the temperature from the IASI retrieval in this darker and but thinner red line, and you can see how they compare to each other. In this case, there's a quite good agreement. Some smaller differences are present in some locations, and you can also see the same for the humidity, where again we have the thick line, a little bit lighter colored line from the model, and the thinner but darker line from IASI. And then we also have two of these yellow-oranges curves plotted here, and they are actually the parcel curves of an air parcel if it would rise from the lowest 500 millibars. So it is actually a parcel with the mixed properties of the lowest 50 millibars, and then or 500 meters, and then if you lift it, it will follow this trajectory. So it can tell you how big the instability is, and especially here you can see that it is in this case much more unstable at mid levels, because or that it is quite unstable at mid levels because it is much warmer than the environmental temperature. And in this case, the IASI parcel, so that uses these IASI measurements, is the one with the thinner lines, is a little bit cooler than the one that the model predicts. So this way you can really look at the reasons for why a particular parameter, especially parameters like CAPE or SIN, would be different in the IASI data than in the model data. You could then see that maybe it is because of a difference in humidity or a difference in temperature. Here is a small video. So here I show you how it works. So this way you would select it, you would select this profile, and then by moving the mouse around, you can really, like this. I hope that it's quick enough that you can see how the profiles, the temperature and the humidity profiles change if you move the mouse over the map. Run it once more. And actually you see that also the CAPE and SIN from IASI appear in this list of parameters. They are really these lowest two values that are plotted there. And you can also see that in some places actually there's like where I've now just stopped this video, that there's quite some differences between IASI and the model, especially with humidity. That is something that we noted more often. The temperature seems to be, well, there's some difference here. It seems to be a little better, but of course that was the most interesting to look at differences. So now I go to the testbed. So we use this for the testbed. So the 2019 edition took place in Wiener Neustadt during 4 weeks in June and July at our research and training center. No corona yet, so we had really people on site there, about 40 people, or yeah, 41 people from these countries. And the task of the participants there is to make experimental forecasts for severe convective storms. And we asked the people when they made such forecasts, or afterwards, we asked them a couple of questions. So question one could atmospheric soundings, such as those provided from Metop or IASI, available within 30 minutes from sensing, be useful for your forecasting work, and in what way? So the result was that out of these 15 groups of respondents, so actually usually people worked in couples or with a small group of 3 people together, they jointly answered these questionnaires, so that they would first have a little bit discussion between them, and then they would answer the questions. And out of these 15 groups, 12 thought that it was in principle useful, But there was also a group, of course, there's always one group that found it a potential source of confusion, and another commented on the need for knowing the quality of the data. Of course, maybe I can briefly go back regarding the quality of the data. We do have always these error bars here right at the Earth's surface here displayed, so that people have an idea of what the range is of possible dew points or possible temperatures that the sounder measures. What the range is of the in which this, it's like a confidence interval. What is the confidence interval that these data have? So one of these groups found that especially important. And there was another person who commented on the experiment of assimilating the data at the Italian Weather Service that it didn't turn out very well, but it was a little bit out of scope, because that was not really what our question was. And then on question 2 was which of these parameters, so we had this whole list of parameters that I showed earlier on, these various varieties of CAPE and of convective inhibition, of humidity, of lapse rates, which ones did you find most useful? And then we got this result that actually the CAPE was the one that everyone was interested in, but also lapse rates were found to be very interesting, precipitable water, and then we got, but we didn't really intend people to answer a profile, but I thought that the dew point profile and the temperature profile were also very interesting and very important to have as a forecaster. And of course, given that we didn't even ask for it, because we asked for parameters and not for profiles, that people answered this by themselves, I think indicates that it is really something that the forecasters would like to have access to and use. Yeah, and then we had the next question, where we asked them, what kind of opinion do you have about this type of data? Do you already think, so option A was here that the IASI products, which of course have limited temporal availability, they're essentially twice a day, there's all the Metop satellites passing. Do you think that that already provides important additional information that you could really use for forecasting? And there were 2 out of these 15 groups that thought so. So that's not too much. Then we have option B, where we said that it is first necessary that more observations become available throughout the day, and that is the option that most of the people chose. So I'm not sure if they thought like, well, I need to really indicate that, of course, the more data I have, the better it is to get a good assessment of what's going on in the atmosphere. That is why they chose B over A. But I guess that that B was really the favorite option, and that we should read from this that indeed the use of the IASI profiles is maybe a little bit complicated by this reduced temporal availability of only twice a day. And then C was essentially the option that you think like, well, they're not very useful, they have limited value, but maybe they're interesting to prepare for the IRS data. So I'm really not so interested in the data now, but perhaps IRS is going to be better ultimately. Then we have question 4, which is a very long text. I think we should have shortened it a little bit. But in the end, the gist was, how important is it to your work that these products are independent of any NWP model? Because as I showed you, we had these forecast model fields, and then in addition we had this IASI data. And one of the thoughts was, of course, that using that data you could compare it with the model and then judge whether the model might actually be a little off in one way or another, or a lot off. Yeah, that of course requires that this IASI data does not somehow in one of its algorithms where it uses all these measurements, that it sort of blends it or mixes in the model forecast data. So this algorithm for these retrievals should really be independent of any NWP model for that to work, and that is what almost all participants indeed agreed with. Of course, we asked this to them in a very open way, but they all of them really confirmed that they think that is really important. So they say we think that it should be independent, so that observations are closer to reality, and then we could compare them with model data. But of course, it is a good thing that the IASI data are also assimilated into a model to improve its performance. So it's like two different ways of using the IASI data. One would be using it to make NWP forecasts better, and the other one is to really use it as something independent to compare with the model. So in addition to this kind of use, you could also use the IASI data, of course, for assimilating it into a forecast. Then question 5 was the question 5 was, how useful do you think this would be for your work if we have not only a single error estimate, because I showed you these confidence intervals, they're right at the surface, but we wanted to ask them if they thought it would also be useful to have error estimates throughout the profile. And we asked them, how useful do you think this would be for your work? And then actually most of the people thought it was useful, but 3 of them thought there was a risk of then overloading the user with information. So I think that stresses the point that we should really be careful with how we present this data, which is apparently data that people really would like to have. They don't only want to know if the temperature is off at the surface or what the possible error at the surface, but also the possible error higher up in the troposphere. But we should take care how we present it to them in order not to overload the data display and not to overload the user with information. And then question 6 was that we of course asked for any additional comments or suggestions, and there were a couple of interesting comments. So let's first go to the visualization suggestions. So they also suggested that maybe we could do a 3D, so really a cross-section view of sounder data. So there will be sort of a feature request for the future. There was also display low-level dew point temperature from IASI as a parameter, because that was not one that we had. And there's a little bit of an issue with that, which I will mention in a moment. Also more clearly indicate the time difference between the sounder data and the forecast model, because we had differences of up to 1.5 hours between the model and the data, or actually up to 2 hours, and of course that can make quite a difference. And maybe to indicate CAPE a little more clearly in this sounding. The general comments were more about the data itself. So half of the groups noted differences in near-surface humidity between IASI data and the model data, or between IASI and surface observations. It was most common in these areas that people looked at, where of course there was a lot of humidity, that there was an underestimation of that humidity. So we thought that perhaps there could be something, there could be some kind of effect that, since forecasters would always look at areas where sufficient humidity is available for severe convection. After all, low-level humidity is one of the ingredients for convective storms. That it is likely that it is some kind of very high percentile of the climatology, and perhaps that would be why retrievals would generally underestimate it more frequently than overestimate it. So in general, we found that especially this near surface humidity was sometimes different quite a bit, and the underestimations were more frequent or much more frequent than overestimations, although overestimations also occur. And the two groups mentioned that the temperature profile seems to be much better. So actually, I will show you a few cases, and one of the cases, indeed, that I will show you shows this very clearly, that the temperature is really very well estimated. So the main outcomes of this study was that most of the participants found the data useful in principle, that forecasters would welcome a higher spatiotemporal availability, and that the profile should stay completely independent of the model data, and that there was some concern about the accuracy of the near-surface humidity data. So what we did as ESSL is that we, besides doing this at the testbed and asking people for their feedback, we also studied the number of past cases. So this would be an example. A particular day in 2017. Actually, this was a day where there was a very big storm in Poland, but here we focus on northern Italy because there the IASI data and the model data show quite an important difference because the cape here in the IASI data is higher in a number of places, like for instance here. See these orange dots in the green area here, orange dots in the blue area, green where there is not even any cape according to the model. So it seems that the model really underestimates the instability in this general area. Here we have another, actually most of the points here, the IASI measurements show a higher cape than the model. And then if we go there and we take the sounding, we can look at the cause for this. And so you have to get used to all the lines once again here. What you can see is that the thin line here from IASI, that is this one here, this thinner red line, it has much higher temperature than the model. The model is here. So while the humidity is really almost the same, especially here in the lower troposphere. So the temperature measured by IASI in this case is really different from the model, and it turned out when comparing this with surface observations that IASI was really better than the model. The model had way too low temperatures in this region. And of course that has potentially a big effect for what happens later on with the storms. So there's actually widespread convective development in this general area later during the afternoon. So this is about 5 hours later. Let's see. Yeah, this was 9 years today, so 6 hours later, 6 hours after the IASI measurements. And that was, I haven't shown the model, but the model did not produce nearly as much convection at this same time. Now another case is this one. On the 5th of June 2019, there was this fast-moving convective system that moved from France across Belgium into Western Germany and the Netherlands. And a big question was, is it capable of severe wind gusts? And we can take a profile here at this black cross and compare the two profiles with each other. And here we see that there's quite a different, that there are quite big differences between the IASI data and the model data. So the model data show here these this layer here, especially here. Oops. So at this level, essentially, where you have high instability because, or at least according to the model, because there's high humidity here, there's a high temperature, a local maximum of temperature. Let me see if I can delete everything in my annotations. So actually, if you would leave the parcel from there, you would probably have a partial curve oops, go a little bit too far to the right here, but something like this in general. So there would be a considerable amount of cape, yeah, in this whole general area here, around here. So if you compare that to the IASI profile, there's much less of that. Unfortunately, it's not depicted by these values here, because this only shows you the surface-based cape, and actually, or let's say the cape from the lowest 50 millibars. So here, you see that actually the sounder has a little higher cape than the model. But if you consider this particular level, which the sounder didn't completely capture, especially this moisture maximum is really missing there, and it also couldn't handle this inversion apparently, or this warm layer, and then it's not really an inversion, but this almost isothermal profile here. Of course, that makes a lot of difference for the interpretation. So in this case, we saw that the IASI wasn't completely able to measure this, but it might also be that this was because there was also already some leading cloudiness in this area. So these are some typical types of differences. Yeah, so here we have the short explanation that indeed in this layer we have this potential instability. Behind the system, it looks a little bit differently, because the model has a wrong timing for this convective system. So the model actually still has this layer there around 800 hectopascal that is potentially very unstable or quite unstable. Whereas the IASI profile has already cooled it down. So actually there, the IASI is probably more accurate because the convective system has already moved through this area. And actually, yeah, this of course causes a decrease in dew point and therefore also a reduction in cape behind the system, which is quite be expected. Actually, because of the extremely strong wind shear in this region, also here ahead of the system. So you can see that from this hodograph here. Actually, quite a few wind gusts were produced by this system that happened last year. It's actually a very mysterious kind of tornado that occurred somewhere around here, where even right before this line moved into this area, there were some very weak leading echoes, and it seems that along one of these small showers that occurred before, some kind of tornado-like phenomenon occurred, but I'm not even able to say it completely for sure, but at least the result was that one car was overturned. So this was a very strange situation. So now I move on to the next case, the 1st of August 2017. In this case, we have a case of a failure of convective initiation. So actually not much happened. And the question is, how well can IASI measure the convective inhibition? So this negative area that has to be overcome by the parcel in order to reach the level of free convection here according to the model, or here according to IASI. And there we see that it has some difficulty in really picturing the details of this temperature profile. So the model in this case appeared to be closer to reality, because actually, if you look at the IASI, there would be much less convective inhibition, although it is still quite considerable. 133 joules per kilogram. That's still substantial, of course. But we can compare to the sounding, and then we are for sure that indeed in this case this huge layer that inhibits the convection was present there in the observation and not as much in the IASI profile. Then I have another case here, a damaging windstorm over Chalkidiki in Greece. July 2019, there was a very strong cell that actually was more like a big convective system that already formed over the Adriatic Sea or the Northern Ionian Sea, and then moved all the way very close to the Italian coast, and moved across the sea, and then went inland across Greece, and then when it arrived on the eastern side of central Greece here, it then re-intensified and produced a very strong windstorm over the Chalkidiki Peninsula, which is right where it is located here. And then the storm afterwards weakened as it moved southeast. In this case, we can see that the profiles at this location of this cross was very well in agreement. Yeah, the agreement was very high between IASI and the model. And yeah, so here the stable layer is really represented quite well, I would say. So it's not always the case, as in this last case that I showed, that these stable layers are not captured. In other cases, they are. Of course, it's still an important question to think about when is it captured and when is it not. In this case, it was done quite well. Then I think this is my final case here, the 9th of August 2019, where we had a number of tornadoes and damaging wind gusts over France, over Belgium, Luxembourg, and the Netherlands. And actually, the top photo here is from Amsterdam. So there was a small tornado right in Amsterdam, and in the right bottom corner, you can see an even more powerful tornado, which was an F2 that occurred in Luxembourg. And on that case, we could also look at the IASI measurements of the preceding morning. So these storms occurred around, I think it was around 15 UTC or 16 UTC. So the measurements are quite a bit earlier than that. But there are some signals here that perhaps the cape that is here indicated with colors again might be higher. Here is some indication, but especially here, because this is the air mass that a few hours later would then move here across Luxembourg. In this case, it seems that the IASI really suggests that there is more instability than the model has. So if we compare the profiles at that location, we can see that the sounder says that there is 900 joules per kilogram of cape, whereas the model has no cape at all. And if you look at this region of the diagram, what the possible reason for that could be is because there was more moisture according to IASI compared to the model. So higher temperature but lower dew point. Yeah, there was some difference there as well. So actually I have, let me see how many cases I have, because I want to take care of the time. We're almost at 40 minutes. So this is really the last case, and then I will skip my bonus case. So here we have a case over the Balkans on 17th of September 2017, which was actually, which I remember because it was during one of the ESSL ECSS conferences where we were actually in Croatia with the participants. And then during that week, we had this event that happened, and that caught quite a lot of attention, especially because it caused quite a number of injuries and fatalities. It was a, yeah, you can see it here, what it looked like. It was a really menacing storm, a supercell storm with extremely high, or sort of embedded supercell storm that had a really high cloud base and very, very strong winds. So if we look at this case, at the IASI data, what we can see here is, unfortunately, in this case, I should have stopped with the last case, of course, unfortunately, in this case, the model even had higher cape in this general region than IASI. Probably in this case, once again, the the clouds that were already happening there made it more difficult perhaps for the IASI profile or the IASI instrument to really capture with the same level of accuracy the profiles. But in this case, indeed, the IASI suggested that there would not be any CAPE that morning, whereas the model already had some CAPE. And I guess we had really more than just a little bit CAPE later during that afternoon when this system happened and moved. Yeah, essentially, well, not from here. It was more from to be able to rotate it here. It was more like there. Yeah, so this was yet another example of the IASI data and how we can compare it. So I will skip this for now. This is yet another case, but I will skip it also in the interest of time. But in total, we have compiled a set of 40 cases. There's always a short overview of these cases in this report that we deliver. There's a model map, so this kind of comparison, and we have a map of ESWD reports there. That is what we did for EUMeTrain. So overall, the conclusions, I think, from both of these exercises, from both the case studies and the testbed, is that the independence of the soundings from the model is very important, because it can only then be used as a check on those models. That the soundings sometimes give an important clue about model bias, but unfortunately not in all cases. It seems that biases in temperature are usually better captured, especially low-level temperature are better captured by IASI than differences in humidity, and that the IASI soundings were appreciated by forecasters. They can typically live with the limited vertical resolution, but the temporal resolution is a more important limiting factor, and that the limited accuracy of the low-level humidity is an important issue, because of course this CAPE and convective inhibition, and therefore the storm potential, is really strongly dependent on the low-level humidity. And we had a few suggestions what we could do next, and I understand that actually tomorrow Sophia is going to talk about some efforts in this direction, to include surface observations to create a better observation-based 3D grid, or at least a better estimate of the temperature and especially humidity at low levels. We also suggested that maybe these retrievals for low-level humidity could be investigated a little more, especially when you have these areas capable of producing severe storms, these conditions that are capable of producing severe storms where low-level humidity is particularly high. We also had as an option that we could visualize gridded difference fields. Perhaps that is something that makes the differences stand out even more than these differences in colors, that you could now see the difference of the dots in the background color. And to implement these error estimates throughout the entire vertical profile, rather than just these small error bars at the bottom of the thermodynamic diagram. And of course, whenever this would be implemented, we would want to go back to the forecasters and ask their feedback on this data. And that is my presentation for today. So I hope this was interesting for you. And if you have any questions, I'll be happy to answer.